Hello everyone. The title of this video is Find the Axis of Symmetry and Vertex of a Parabola. Each exercise I'm going to do in this video is taken directly from a free online textbook at openstacks.org, and it's their Intermediate Algebra 2nd edition text. I'm in section 9.6 titled Graph Quadratic Functions Using Properties. And I'm working under the heading Find the Axis of Symmetry and Vertex of a Parabola. I'm only going to be doing the even numbered exercises, so number 238 and number 240. Right, those don't have solutions, whereas the odd numbered ones, you click on the links, you can see the solutions in the text. I'll also have timestamps for each of these, right, so you'll see in the description of the video below. Example 1's timestamp will be for number 238, and example 2 will be for number 240. I also request that when I start a new problem, that you pause the video and try to work on it yourself first before watching me do it and comparing. Because if you're just watching me do these questions and not practicing yourself, chances are you're not learning all that much. Alright, so I'm going to start with exercise 238 here. Now in both of these, the instructions are A, find the equation of the axis of symmetry for the parabola. Right? Remember, the graph of a quadratic function is a parabola. And part B is find the vertex of its graph. So I'll talk a little bit first about what is the axis of symmetry of a parabola and what is the vertex of the parabola. Right. So I've got these questions written out. Right. So example 1, exercise 238. Right. But like I said, before I even get into this exercise here, talk about parabolas, right? So, remember, quadratic functions take the following form. Our quadratic functions look like this: f of x or g of x or y equals a times x squared plus b times x plus c, right? Where a, b, and c are real numbers, and a is non-zero, right? Because if a were 0, then it would be a linear function, not a quadratic function. And you may recall that the graph of such a function is, is called a parabola. Right? And it could be either opening up like this, looking like a kind of a U shape. That's if a is positive. Remember that if the lead coefficient was positive, the parabola will be opening upward. Or, right, if a is negative, right, if this lead coefficient is a negative number, the parabola is opening down. Right? So this is something I've pointed out in a previous video. Now, these shapes are symmetrical about a vertical line. So there's a vertical line that kind of cuts them in half. Right, so I'll do a little dashed line here. See, if I were to fold along this line, the two halves would meet up. Right? If I go from this line to the right and then to the left the same number of units, you land on the graph. Right? This vertical line, and I'll do the same thing over here, that cuts the parabola in half, two halves there, is called the axis of symmetry. Right, so this here is also, the axis of symmetry for this parabola. Can't spell. All right, symmetry. Now, given a function like this, given a quadratic function in this form, f of x equals ax squared plus bx plus c, the equation for this vertical line, the equation for the axis of symmetry, it will be the following. And I suggest you either memorize this or have it readily available. Is the following. It'll be x equals some number. Now remember a vertical line has an equation of x equals a number, right? X is always the same number. The x coordinate's always the same on a vertical line. And it's x equals the opposite of b, right, which is the linear coefficient, this b here, divided by 2 times a, where a is the quadratic coefficient. Right, so I'm going to put that in a little box. This is huge, right? Please get to memorizing this. Right? And I'll use this in our exercises as well. And I'll show you on the desmos.com, free graphing calculator website. All right, so x equals the opposite of b divided by twice a. All right, this is going to be the equation of this vertical line that cuts the parabola in half, right? That is a line of symmetry for the parabola. All right. Now they also mention the vertex in the instructions. Find the vertex of the graph of the parabola. The vertex is the point of the parabola that's on the axis of symmetry. So this point right here, this would be the vertex. And when a is positive, right, when the parabola is opening up, the vertex is the lowest point of the parabola. Has the lowest y value, the lowest output. But when a is negative, right, when the lead coefficient is negative and the parabola is opening down, the vertex, right, this point of the parabola that's on the axis of symmetry, is the highest point, has the highest y value, the largest output. Right, so again we have the vertex, which, in this case, again, if the parabola is opening down, is the highest point. All right, and then something else to remember is how to find this point, right? How do I find the coordinates of this point? Well, the vertex is the following ordered pair. Since it's on the axis of symmetry, this opposite of b over twice a, this is the x-coordinate of the vertex. So the x-coordinate of the vertex is, negative b over 2a. Right? That's coming straight from the fact that the vertex is on the axis of symmetry. And then to find the y-coordinate, I just plug it into the function, right? This is f of x, so the output would be f of negative b over 2a, and whatever that output is. Okay. So again, I'll box this. This is important for our purposes in this video. And you should know these things, especially the negative b over 2a deal, right? If you're given a quadratic function in standard form like this, or a general form, x equals negative b over 2a is the equation of the axis of symmetry, and then that is also the x-coordinate of the vertex. You plug it into the function, get f of that, right, and then you get the y-coordinate, and then you'll have the coordinates of the vertex point. Wonderful. All right, so I'm going to keep referring to this. I'm going to keep bringing these little formulas up for our exercises, and I'll show you on a graph as well. All right, so number 1, exercise 238 in the text. we're given a function with a standard quadratic polynomial here. F of x equals 1x squared plus 10x plus 25. So the value of a, right, would be 1. That's the quadratic coefficient. The value of b would be positive 10, right, the linear coefficient, the linear term. And the value of c, which really doesn't matter, would be 25. The value of c does not matter when finding the axis of symmetry. Alright, so the axis of symmetry for this particular parabola. Remember, the formula is this. It's the vertical line, x equals the opposite of b divided by twice a. Right? So that in this case would be the opposite of 10, right? So negative 10 divided by 2 times a is 1. This is negative 10 divided by 2. That's negative 5. Right? So x equals negative 5 is the answer for part A. Right? Find the equation of the axis of symmetry. Alright, and what I'm going to do is I'm going to start showing you how we're going to make our drawings of parabolas from here on out. So off to the side, here's the xy axis. And x equals negative 5. Right, so I go to negative 5 on the x-axis. And I'll draw this vertical line in, but dotted, right? It's not actually part of the parabola. But this line, this vertical line, is going to cut the parabola in half, right? So there's the line x equals negative 5 dotted. Right? All right, now I'm going to find in part B, right, find the vertex of the graph. Now the vertex will be some point, the point of the parabola that's on this line. All right, so for the vertex, I know the x-coordinate is negative 5. Right, it's going to be input negative 5, and then the output will be whatever f of negative 5 is. Right? I'm just plugging negative 5 into the function. So let's find that. Right? What's f of negative 5? Well, that would be, according to this rule, negative 5 to the second power plus 10 times negative 5, and then plus 25. Well, this is 25 minus 50 plus 25. This is 0. So the vertex has coordinates, negative 5 for the input, 0 for the output. And that's the second part of what we're asked to find, right? Part B. Now I'm going to plot this point. Negative 5 comma 0, that's on the x-axis. That's this point right here. Alright, and then I'm going to show you really quickly, and we're not asked to do this, but I'm going to show you really quickly how we're going to very quickly plot parabolas. Find one other point. Right. So here's another point on the parabola, something other than the vertex. Right, this is extra. Another point would be, an easy point to find would be, if I plugged in 0 for x, clearly the output would just be 25. Right. So I'm going to plot that. Now, I'm just going to say these are every 5 here. I know that the y-axis notches are different than the x-axis notches here. So 5, 10, 15, 20. Let's say that's 25 on the y-axis. I'll plot this point, 0, 25. There's the y-intercept of this graph. And then using the symmetry, we find another point on the parabola, a point on the other side of the axis of symmetry. So look how that would be done. See, if I go do this in a different color. Here's the point 0, 25, right? That's on the parabola. That satisfies this equation. If I go straight to the axis of symmetry from this point here, perpendicular to the axis of symmetry, that's 5 units, right? That's going left to right. That's 5 units. This is 5 units right here. So because this is a line of symmetry, if you go 5 units on the other side, you'll land at another point. So I go 5 units straight across. Here's another 5 units. Well, where would that should land me at another point on the parabola. That'd be at -10. Right, -10, and now let me draw that in a little better. But -10, 25 should also be on this. Right. So you see what I'm saying? Like, I hope you do. So the ordered pair -10, 25 would also be on the parabola. That's this point I plotted here. And then graph. Alright, we can draw a very, very rough sketch knowing that this is a parabola, right, the graph of a quadratic function, opening up, right, the lead coefficient's positive. And remember, if it's opening up, the vertex is the lowest point. So I'm going to draw a little curl here, letting me know that vertex is the lowest point, and then just run through these other 2 points, making it look parabola-like, right, like that, up forever that way, and up forever, going through the point -10, 25, and up forever that way. And very, very rough sketch of the parabola. Now let me show you a much better picture, of course. There's a free online graphing calculator at desmos.com. And I'm just going to enter the function we were given as is, f of x equals x squared plus 10x plus 25. And I'll also enter let me show you the axis of symmetry, x equals -5. And I'll make it like a dotted line. Edit this and turn it into a dotted line. Right, do you see the symmetry, right, around this purple line here? And there's the vertex, right, -5, 0, the lowest point on this parabola that's opening up. And then if I scroll up, let's go to, remember that other point I plotted was 0, 25, right, 0, 25. And look at the symmetry, right? That's 5 units to the right of the axis of symmetry. See, if I go 5 units to the left, there's -10, 25. Right? The other point I plotted. And then once you plot the vertex, and a point on either side of the axis of symmetry, you can make a very rough sketch by hand, right? My sketch by hand is a very rough one, but it's got the same shape as you saw on the Desmos site. All right, so axis of symmetry, x equals -5, vertex -5, 0, right at that point. That's all we're asked to do. The rest of the stuff, actually graphing it, is just a little extra for you. Okay. Next question. Alright, so it's the same thing. I'm asked to do the same 2 things. Find the axis of symmetry equation, and then the vertex. Right? Like I said, I'll go a little extra and actually graph it as well. Draw a rough sketch of the graph of the parabola. So this is exercise 240 in the text. Right? So we have f of x equals, and then a standard quadratic, right? Quadratic polynomial ax squared plus bx plus c. The value of a this time is -2. Don't forget negatives, right? The value of b is linear coefficient, which is -8, not just 8. Right? Don't forget the negatives. And the value of c, which again really doesn't matter when you're finding the axis of symmetry, is -3. Now, because the lead coefficient is negative, right, this should be a parabola opening down. Right? We're going to see this parabola opens down when we graph it later. All right, so first the axis of symmetry. Is x equals, and I'll write out the little formula once again, the opposite of b divided by twice a. Alright, so this is, now the opposite of -8 is +8. Right? So I have +8 in the numerator. 2 times a is 2 times -2. That's -4 in the denominator, and that simplifies to just -2. So x equals -2 is the axis of symmetry. This vertical line will, cut the parabola in half, if you want to think of it that way. And I'll start drawing. All right, so here's the xy coordinate plane. Go to -2 on the x-axis here, and I'm just going to draw a little dotted vertical line. All right, here's the axis of symmetry. X equals -2. Right. And now the vertex, right, should be on this line. Right? The vertex is the point of the parabola that's on the axis of symmetry. Right, so the vertex, right, should be the point with an x-coordinate of -2. Right, I know that much. And then the y-coordinate is just, what's the output when I plug -2 in? What's f of -2? So I need to find this, right? So f of -2 is -2 times x squared, so -2 times -2 squared, minus 8 times -2 minus 3. Alright, so this is, remember you do powers first, right? -2 squared is 4. -2 times 4 is -8. Alright, then we have -8 times -2 is +16 minus 3. This is 8 minus 3, this is 5. Alright, so the ordered pair -2, 5 is the vertex of this parabola. Right, and you can stop there if you want, right? That's all they asked for. But like I said, with example 1, I'm going to continue on and actually graph the rest of it. Alright, so 1, 2, 3, 4, 5. So -2 for the input, 5 for the output. That's the vertex. And like I said, we know that this parabola should be opening down, right? The lead coefficient is negative. So let's just, all I need now is to find a point on the right side of the axis of symmetry and a point on the left side. Once you have a point on either side, you can make and the vertex, you can make a very rough sketch of the graph. Alright, so another point, right, a point that's not the vertex. Now an easy one again here would be just plug in 0. 0 for x, and if I plug in 0 for x, you'd get -3 for the y, for the output. So 0, -3. So 0 input, -3 output, and I plot that point. Right? And then using symmetry, we can find another point, right? A point on the other side of the axis of symmetry that will be on this parabola. Well, 0, -3, that's 2 units to the right of the axis of symmetry. So I just need to go 2 units to the left, to -4. Right? So -4 will also give me an output of -3. And you can test this. Right? Plug in -4 for x into the function, and you'll see that you'll get -3 as an output. Right? So -4, -3. And like I said in the last example, once you have the vertex and a point on either side of the axis of symmetry, you can make a very rough sketch, right? So again, make it a little curvy up top here, and then passing through these points and going down forever that way, and then down forever that way. And again, there's a very, very rough drawing of this parabola, right, that's opening down. Right, and once again, I'll pull this up on the Desmos site and we can take a better look at it. Right, the function given was f of x equals -2 times x squared minus 8x minus 3. And look at that, right? See, there's -2 comma 5. See, the highest point is definitely the vertex. Here's 0, -3 that we also plotted, and then 2 units to the. I'll put in the axis of symmetry too. X equals -2. Make it a dotted line because it's not actually part of the parabola. All right, so you see the symmetry, right? And then yeah, there's 0, -3. That's 2 units to the right of the axis of symmetry, and then you go 2 units to the left, and there's -4, -3, which we also plotted. And then once I had the vertex and these 2 points, a point on the right, a point on the left of the axis of symmetry, I could make a rough sketch. All right. Now, in a future video, we're going to not only talk about finding this y-intercept, right, this point on the y-axis, but also finding these points on the x-axis, right, finding the x-intercepts as well and using those to help me graph also. But for right now, all they asked us for was the axis of symmetry, x equals -2, and the vertex, the point -2, 5, right? We'll talk about making graphs. I mean, you already know how to graph these now, right? I've already shown you just here in this video. But we'll go into a little more detail and find the intercepts, the x-intercepts and y-intercepts in a coming video. All right. So hoping that watching me go through these 2 questions here, these 2 examples, help you out when you're asked to find the axis of symmetry and vertex of a parabola on your own. And thank you very much for watching.